Hello everybody. In this video, I'm going to attempt a mock exam on AWS Certified Developer Associate. So let's get started. First question. A serverless application needs to implement distributed tracing across Lambda functions, API gateway, and external services to troubleshoot performance issues. Which service should be configured? Option 1. CloudWatch logs with correlation ID. Option 2. AWS X-Ray with active tracing. Option 3. CloudTrail for API call tracking. Option 4. Custom logging with request IDs. I would go with option 2. Let's see if it is correct or not. That is the correct answer. AWS X-Ray provides distributed tracing across AWS services, including Lambda and API Gateway. Enable active tracing to automatically trace requests across service boundaries and identify performance bottlenecks in serverless applications. Let's go to next question. Question number 2. An application stores user activity logs in DynamoDB with user ID as partition key and activity timestamp as sort key. Which application needs to query activities within specific time ranges efficiently? What query should be used? What query approach should be used? Option 1. Query with key condition expression using between operator. Query with filter expression with for timestamp range. Scan with filter expression for timestamp range. Use batch get item with calculated timestamp keys. So the application stores user activity logs in DynamoDB. The application needs to query activities within a specific time. Let's go with question 2, which is the incorrect answer. The correct answer is query with key condition expression using between operator. Query with key condition expression using between operator efficiently queries items within a timestamp range using the sort key. Filter expression is applied after the query and less efficient. Scan is inefficient. Batch get item requires knowing the specific keys. Okay, let's go to third question. A web application allows users to upload files and needs to scan them for malware before making them available for download. The scanning should be automatic and efficient. Which architecture should be implemented? Option 1. Upload to quarantine bucket, scan with Lambda, move to public bucket if clean. Scan files during upload in the web application. Use S3 lifecycle policies to trigger scanning. Implement periodic batch scanning for all files. Let's go with quiz solution 1 because that seems to be the most practical. Uploading to a quarantine bucket allows isolation of potentially malicious files. Lambda functions triggered by S3 events can perform malware scanning and move clean files to public bucket. This provides automatic secure file processing without exposing users to malware. Let's go to next question. Question number 4. A social media application uses SNS to send notifications about user interactions. The system needs to handle notification preferences and avoid sending unwanted notifications to users. Which approach provides the most flexible notification management? Use SNS subscription filter policies based on user preferences. Implemented preference checking in Lambda functions before SNS. Create separate SNS topics for different notification types. Use SNS message attributes with client-side filtering. I think option 1 is the most practical, but let's see. That's wrong. Option 2 is the correct answer. Implement preference checking in Lambda function before SNS. Lambda functions before SNS allows complex preference logic, database lookup, and dynamic filtering based on current user settings. This provides the most flexibility for managing user preferences. SNS filter policies are limited to message attributes. Separate topics create management overhead, and client-side filtering doesn't prevent unwanted message delivery. Let's go to the next question, question number 5. A data processing pipeline uses Event Bridge to coordinate between services. The pipeline needs to implement back pressure to prevent overwhelming downstream service during traffic spikes. Which approach provides effective back pressure control? Select 2. Option 1. Use Event Bridge with SQS queues as buffers between services. Configure Event Bridge retry policies with exponential backoff. Implement rate limiting in Event Bridge target services. Use Event Bridge input transformers to throttle events. Configure Lambda resolved concurrency for processing limits. So we have to select 2. The first one seems to be correct. Let's go with option 1 and 2. Option 1 is correct and option 2, 3, 4, 5 is correct. SQS queries provide natural back pressure through buffering and allow downstream services to process at their own pace. Lambda resolved concurrency directly limits processing rate and provides back pressure. Retry policies handle failure, not back pressure. Rate limiting in target doesn't provide system-wide back pressure. Input transformers don't provide throttling capabilities. Okay, let's go to question number 6. Our data analytics platform caches query results that vary significantly in computation time and data size. Some queries take seconds while others take hours to compute, and results range from small aggregates to large datasets. Which caching strategy optimizes for mixed query workloads? Select 3. Mixed query workloads. Implement query specific TTL based on computation cost. Yeah, this seems the obvious choice. Use cache compression for large result sets. Configure different cache tiers for different result sizes. Yes. Implement background refresh for expensive queries. Use write throughput caching for all query results. Store query metadata separately from results. Let's go with these 3. So the correct answer is use query specific TTL based on computation cost, use cache compression for large result sets, and implement background refresh for expensive queries. Let's see the explanation. Query specific TTL ensures expensive queries stay cached longer, maximizing the benefit of computation cost. Cache compression reduces memory usage for large result sets. Background refresh keeps expensive query results concurrent without user-facing delays. Different cache tiers add complexity, while write-through doesn't optimize for computation cost, and separate metadata storage doesn't address the core optimization need. Next question, question number 7. Our development team needs to create an IAM policy that allows developers to create and manage Lambda functions in development environments. but prevents any access to production resources tagged with environment in equals to production. Which policy structure enforces environment-based access control? Use condition keys to deny access to resources with production tags. We have to select 2. Create separate AWS accounts for development and production. Use resource-based policies on production resources. Implement tag-based access control with string not equals condition. Use IAM permissions boundaries for environment isolations. Let's go with option A and D. Those are the correct answers. Condition keys with deny effects can prevent access to production tagged resources, and string not equals conditions can allow access only to non-production resources. Separate accounts provide stronger isolation but may not be feasible. Resource-based policies don't prevent IAM access, and permission boundaries set maximum permission but don't enforce tag-based restriction directly. Let's go to question number 8. Our development team is using AWS code commit for their Git repository. They need to set up branch-based development where feature branches are merged into main branch through pull requests with code review requirements. Which code commit features support this workflow? Pull request for code review and collaboration. Branch protection rules to prevent direct push to main branch. Approval rules to require review approval before merging. Automatic code compilation on branch creation. Built-in deployment to EC2 instance. Integrated load testing capabilities. Let's go with option 1, 2, 3. Those are the correct answers. Code commit supports pull requests for code review. Branch protection rules to control access to branches, and approval rules to require specific reviews before merging. Code commit doesn't include automatic compilation. That's code build. Deployment capabilities, that's code deploy, or load testing, that will be separate tools. Question number 9. A developer wants to create a CloudWatch dashboard to visualize application performance metrics and set up real-time monitoring for their team. Which CloudWatch metrics are automatically available for Lambda functions? Select 3. Duration, execution time for function invocations. Invocation, number of times the function is invoked. Errors, the number of invocations that result in function errors. Memory usage, actual memory consumed during execution. CPU utilization, processor usage during execution. Network I/O. Okay, let's go with 1, 2, 3. Those are the correct answer. Lambda function automatically provides duration metrics, execution time, invocation metrics, function calls, and errors. Tracking failed execution. Memory usage, CPU, and networking are not provided as standard Lambda metrics in CloudWatch. Question number 10. A Lambda function is experiencing throttling during event-driven processing, and the team needs to implement a solution that handles both throttling and error scenarios comprehensively. What comprehensive error handling strategy addresses both Lambda throttling and other error scenarios? Select 3. Option 1. Implement exponential backup with jitter for throttling retries. Option 2. Configure dead letter queues for failed invocations after retry exhaustion. Option 3. Use different retry strategies for throttling versus other error types. Disable error handling to improve performance. Option D. Option E. Use synchronous invocation for all error scenarios. Option F. Implement circuit breaker patterns for cascading failure prevention. Let's go with option 1, 2, and 6. 6 is wrong. The right option is option C, which is use different retry strategies for throttling versus other error types. Explanation: comprehensive error handling includes exponential backup with jitter for throttling specific retries, dead letter queue for capturing failed invocations after retries has exhausted, and different retry strategies for different error types, throttling versus application errors. Disabling error handling reduces reliability, and synchronous invocation doesn't improve error handling. Let's finish our exam, and I've got 50% score. Let's review our questions again. Question 1 is correct. X-ray, AWS X-ray with active ray tracing is the way to go for service applications distributed tracing. Option 2 is the right answer is query with key conditions expression using between operator for the sort key that is separated by date. Option 3 is to scan for viruses and malware. You have to upload the objects to a separate bucket, and then use a lambda function to scan and move it to the public bucket so that people can access from. Question 4, for a social media application and the user preferences to get notified. Option B is the right answer, where you have to use a lambda function to check the preferences before using the SNS or sending it to the SNS topic. Option 5, data processing pipeline uses event bridge to coordinate between services. How do you implement back pressure to prevent overwhelming downstream services? The correct answer is option A, use event bridge with SQS queues as buffer between services. So SQS queue can handle a lot of messages when there is a huge spike, so that the client can take its time to process the message slowly. And you can configure lambda reserved concurrency for processing limits. That way it will process at a maximum limit and then it will not go beyond that. Question number 6. The data analytics platform, there are various type of queries and their results, and they take various amount of time, and the result is also, some results are small, some are big. What are the caching strategy to use in this kind of scenario? So the first option, correct option is use query specific TTL based on computation cost. This way the query that took a huge amount of time will be cached for longer time for maximum benefit. Second, use a compression, cache compression for large result sets. And the third is implement background refresh for expensive queries. So this will not keep occupying the queue, and the queue will be available for next request. Question 7. Development team needs to separate between their resources and production resources, and where the resources are just separated by a tag. How do you prevent environment-based access condition? You can use a condition keys to deny access to the resources with production tags. This is basically in the resource policy. You create a policy for that resources, and then you use a condition key to separate the access based on the tag, and the implement tag based access control with string not equals condition. Question number 8. So development team is using AWS code commit for their Git repository, as they want to implement certain conditions before they merge the code to the main branch. They want some reviews in the code, in the feature branch, and a lot of other things. So how can they implement that? So what you can do is pull request for code review and collaboration. They have to implement pull request, branch protection, so that they can commit directly to the main branch, and then require some approvals before the pull request is merged into the main branch. Question 9. Developer wants to create a CloudWatch dashboard for their application. Which of the metrics are readily available for Lambda functions? So the Lambda function by default emits metrics for duration, invocations, and error. So option 1, 2, and 3 are correct. Question number 10. A Lambda function is experiencing throttling during event-driven processing. What comprehensive error handling strategy addresses both Lambda throttling and other error scenarios? So there are Lambda throttlings as well as other application errors. What are the 3 strategies you pick to handle those kind of scenarios, error scenarios? So implement exponential backup with jitter for throttling retries. Configure dead letter queues for failed invocation so that it doesn't continuously create an issue and the message that is creating an issue gets moved to off dead letter queue. And then the last option is use a different retry strategy for throttling versus other error types. That's all. Let's wrap up our mock exam. Thank you guys for watching this video. See you guys next time.